Today I'm extremely excited to present you our latest open source framework, Lightbend Lagom. Lagom is a framework for building reactive microservices on the JVM. So maybe you wonder why we picked that name. So let's start by that and then get into the technical details. So Lagom is a Swedish word, and as you may know, we get a lot of people that are Swedish in Lightbend, but that's not the reason why we picked Lagom actually. So Lagom is a Swedish word meaning adequate, sufficient, just right. Depending maybe on your culture, being adequate could also be a negative quality. It doesn't always feel like, it doesn't always look like a positive thing. But actually for a Swedish to be Lagom has definitely a positive attitude. And I can't really explain you what it really means to a Swedish person to be Lagom. But to some extent, it means to be just not too small or not too little, not too big. You just want to be humble and somewhat right. And that is pretty much what Lagom means. And we felt that Lagom was a really good name for a microservices framework because often people get focused on the micro part of the microservices name when they discuss microservice. And that is really not the essence of what microservices is. Lagom is about right-sized services. You should be focusing on finding the right boundary requirements of your services. You should be thinking about what needs to be together and what actually can be separate so that doesn't need to depend on each other. So you should try to build Lagom services. Here's the agenda. We'll start with the rationale. Why did we create a Lagom? Why did we create yet another microservices framework? And then we'll dive into its main components, the development environment, the service API, and the persistence API. My goal with the presentation is really to give you a broad overview about all the different components that make up Lagom, so that then you should be fully equipped to just go and explore the sample application that we have available and start from there and build your first sample app using Lagom. And at the end, I'll also discuss how you can run in production Lagom. So Lagom gives you an opinionated view on how you should be building microservices that adhere to the reactive tenant. Lagom is built with akka and play, so it is fully asynchronous and unblocking at its core. And furthermore, we advocate the use of event sourcing and CQRS. And the reason for doing that is because we feel, that, and in our experience it is the case, that it is easier with this architectural pattern to build systems that are truly reactive. Another point that we actually spent a considerable amount of time designing is the development experience. We want you to be at the center of the whole experience, and it should be that simple to run your services while developing it. So we have built a development environment that to some extent feels like play. If you're familiar with play, there's going to be things like hot reload whenever you make a change in your services so that you never have to switch from your preferred IDE. You just keep coding, and underneath the system will take care of reloading things so that if you want, you can just open the browser and test, or from the command line, and just test what you just changed. There's going to be no script that you'll have to maintain across your teams and possibly across different machines. We have seen people having these horrible scripts to maintain for all different kind of environments, and that usually never works when there is a new guy coming to your project and that he has a slightly different environment than you're on, maybe for days before he can actually be up and running on your project. Well, with Lagom, it should take literally minutes to have a new guy in your team being able to be productive. And last but not least, inter-service communication in Lagom just works. It means that it is really simple for you to have one service to communicate with another. And we'll see how that works. And finally, it actually doesn't just take care of the development. It doesn't just help you developing systems of microservices. It also helps you running them in production. So I'd say that when you evaluate a new microservices framework, one thing that you should be paying attention since the very beginning is, how are you going to run these things in production? You should ask yourself a question like, are your services going to locate and communicate with each other? Are they going to, how will you monitor them? How will you upgrade them, right? There are plenty of questions that you need to ask yourself. And with Lagom, we also have an answer to that, and that is Lightbend Conductor. It's our orchestration tool. I'll talk a bit more about this toward the end. So under the hood, we're using SBT. So you'll have an SBT build file. We're using SBT also because it's an extremely powerful tool if you want to build a developer experience, development environment, and that's how we did it in Lagom. As I mentioned, we use Play and Akka, specifically Play to the 5 and Akka to the 4. The components of Akka that we're using is clustering, streams, and persistence. Cassandra is the default data store. I'll just emphasize that that doesn't mean that you can't use Lagom with a different data store. You can use whatever data store you want. But Cassandra is the default, and I'll show you that we built some abstraction around it to simplify doing event sourcing and CQRS. Jackson is used for JSON serialization and Juice for dependency injection, just like in Play. Enough slides. It's time to have a look at the development environment. So here I have a chirper application that we built. Is a Twitter-like application, basically. And I'll just type SBT. This will load the SBT console. And once it's loaded, we will be able to see how you can, with a single task, so with a single command, you can run all your services. You don't have to do any. This is actually how a new guy coming to your project would do it.
Mirco,
yes?
Can you make it bigger?
Yes, sorry. How is that? Is it better? Then this is even better, I guess. Good. So, run all is the one thing you want to remember when you are in the development environment of Lagom. So I'll just type run all and hit enter. And as you can see, it's going to start doing some stuff. So what's happening underneath is that we're going to start all the different components that are needed by your services. So in this case, I think we have 4 or 5 services defined in our Lagom project. And so, because some of them, for instance, need Cassandra, what's happening at the very beginning, let me scroll up. What's happening at the very beginning is that we're starting an embedded Cassandra server, so that you don't have to install one on your local machine. Once that is started, it gives you the address on which you can reach it. And right after that, we start the service locator and the service gateway. These are 2 components that we built expressively for the development environment. They're not to be used in production. In production, as I said, there is conductor, and it already takes care of these things. It already has a service locator. You don't have to worry about these things. But in development, we have started this service locator, and the reason for having a service locator is because you want your services to be able to communicate with each other, right? So what happens is that whenever we're going to start these different services, which you can see on different ports, they're started. The first thing they're going to be doing is registering themselves, so their name and their IP, to the service locator, so that later on I show you what is the API for having services to communicate one to the other. But basically what's going to happen underneath is that these services will be contacting the service locator and say, hey, I want to talk to this guy. Can you give me his address? And once I have the address, I can actually call the endpoints exposed by that service. And this is all happening underneath. You don't have to do anything. It's all taken care of for you. Good. So services are up and running. So let's see how this application works. Let me make it bigger. So here it is. It's a very simple Twitter-like application. I just have a couple of tweets. I compose new messages. So yes, I'm Mirco. I say, hey everybody. You can add friends. I can log out, and you can see the feed of different users if you want. So very simple. Good. Let's get back to, so one thing I want to showcase now is that I'm going to make a change in the code and you'll see that it will automatically be picked up by the development environment. The service that I changed will be recompiled and reloaded automatically for you. You don't have to do anything. And you'll see that there's going to be a change when I refresh the application. So again, for the purpose of showing you how this works, I just have a very simple hello. So the moment I save, I'll just switch to the command line, and you see that the change is being picked up. So it's being recompiled, and it's being reloaded. So right now, if I reload this page, and I need to reload it only because, well, the hello print line that I added, it will be triggered only at the moment I reload it. That's why. Otherwise, if it was something that would be, I would say, triggered eagerly by the application on reload, we would have already seen the side effect. So now I reload it, and if I go back to my command line, I see that the hello print line is there. So that really means that you never need to focus on that command line. You always stay in the code and possibly in the browser if you're testing things. Good. So there are a couple of other things I want you to notice. One is that we're actually accessing our service through localhost 9000. So I'll just show you. So we have a service gateway that is being started on localhost 9000, as you can see there. So the service gateway is just, I say, a proxy to your services. So what it means is that you have a stable port that you can use for accessing all your services that are being exposed on different ports, as you can see there. Like there are all these random ports that are being used, and you don't actually want to remember those ports. For instance, you can imagine that you have an application where you want to insert data in this application before maybe running some tests from the command line. Well, you don't want to remember those ports because those scripts, you may want to share them across your team because they're just useful to load the testing environment. And so you can just do that through the service gateway. And another thing I want you to notice is that the actual port that are being selected for running the projects are going to be consistent not just in your machine, so meaning that if I stop the development environment and I rerun it, it's still going to be the same port, assuming it's open, assuming it's available. And the other thing is that across your team, actually, the same port is selected for the same service. This, again, it's all taken care of for you by the development environment. You don't have to think about these things, but I thought it was nice to know. And other random things is that, of course, you have lots of flexibility. For instance, if you want to run your own local Cassandra, you can do that, and you can just turn off the one that is embedded. And there are all sorts of flags that you can go and uncover in the SBT plugin. Good. So let's get back to the presentation. Is there any question about the development environment? All right. So this actually got wrong. Project shouldn't be highlighted, so just look at it as if it wasn't highlighted. So the idea is this actually gives you the anatomy of a Lagom project. So what you see, the one thing that I really want to emphasize, and that is why it is emphasized, is that for every service, you'll have an API project and an implementation project. The API project will declare the interface of your service. So the endpoints, and now these endpoints will, what is the serialization that you're going to be using, and all this, I would say, metadata about your service and how your services can be accessed. An implementation project, well, it actually provides the implementation of that API. So you'll always have that the implementation project depends on the API project. And in this case, we only have one service in this Lagom project, so the Hello World service. But you'll have more and more services in your project, and you'll just continue adding them within the same build file. And the reason why you want to try to add them within the same build file is because you get this really nice development experience, meaning that you have a single command to run all of them, and that is really convenient. Of course, there is a point after which one machine won't make it. Like, it's just too much resources that are going to be consumed, and there are ways to split it and still be able to use the development environment that we provided. And a couple of things I didn't mention about the Lagom build is that we're using Scala 2.11 and Java 8. Java 8, well, for many reasons, but a simple one is that both Akka 2.4 and Supply 2.5 use Java 8, so we had to anyway, and even though we wanted to. And Scala 2.11 for the moment, so no support for Scala 2.10. All right, let's get into the service API. So we want to create a really simple hello world service. So this is what we're going to be doing here. So the first thing we want to do is we have our API project, as I mentioned before, and in that project we're going to add this single trait. We named it hello service that extends the Lagom service trait. So far, so good. And now we need to provide an implementation for this descriptor method that is inherited from the Lagom service interface. And a descriptor, it's just basically providing the name of your service together with the set of endpoints that your service is exposing, coupled with metadata about how the service and its calls are to be served. So for creating a descriptor instance, we have Fluent API. So you start by providing the name of your service. In this case, it's hello service. And then you have this call to with calls. And this is where you provide the set of endpoints that you want to expose. We have only one in this case. It can be reached at the static path hello. That is why we're using named call. Then I'll show you something different. It will get clear as we get through the talk. But at the moment, named call just means that I want to expose a static path. That path is hello. And then on the right-hand side, the second argument, I'm passing the method. So if you're familiar with play, it could be your action method that you want to execute when that static path is being called. So just a small syntactic thing, the underscore after the say hello method call is needed because you want to lift the method into a function object. That's why it's there. And then we have a single abstract method declared in our service. And this is basically what our implementation project will need to implement, right? It has to provide the logic. So what is that our service should be doing when the say hello method is being called? And the type of this method is a service call, string with two type parameters, string. The first one is the request type, and the second one is the response type. So I was just telling you about service call. As I say, two type parameters, and it has a single method invoke that takes the request message and returns a response sometime in the future, so asynchronously. So request is the type of the incoming message. Before in our hello world example, it was a string. It can be any Scala type. And response is the type of our outgoing message. JSON is the default serialization format. So when I say it can be any Scala type, I mean that it can be any type as long as you can serialize it, basically, as long as there is a way for either the framework or you provide an explicit way, serialization. And then there are two kind of request and response messages. What we have seen before, it's a strict message, and we'll see what it means. And then we also have support, built-in support for streaming. And we'll actually see an example of this too. So this is what we have seen before. This is declaring a strict message. So the service call, the fact that I'm passing a plain Scala type string, it can be any other type, that means that the request and response types will be strict messages. And that basically means that your messages will be fully buffered into memory before your logic is going to be executed. But there are cases where you actually want to stream. And, well, we don't really, I haven't personally seen any other framework that any other microservices framework that allows you to do that as a built-in feature. And what you can do is saying, I want to actually stream, not just, I don't want to just send one response, I want to send a stream of responses because this will happen maybe at some interval, it's expressed in this service. And all I need to do as a user is saying that it's a source of some type. So source is a NACA stream source, if you're familiar with it. If you're not familiar with it and you want to know more about NACA stream, there is actually a session, I believe, tomorrow by Conrad at 11. I'd highly encourage you to go. So what NACA stream gives you is back-pressured asynchronous handling of messages. So meaning, what that means is that the sender of the message will never overwhelm the receiver of those messages. Basically, we'll always go at the speed that the message, well, or almost at the speed that our consumer can consume those messages. And this is a very nice property. And for streaming, Lagom will select the transport protocol, and in this case will be WebSockets. So in the future, we do plan to provide alternatives so that you can plug a different streaming protocol if you want. But at the moment, it's only WebSockets. And for strict messages, underneath, we're using HTTP for the moment. Again, we'll have other transport protocol in the future, but that's what it is at the moment. So another thing is before we talked about name call in our service, here we're using path call, right? So before it was a static path. Now it's a dynamic one. In fact, we want to extract a portion of that path and pass it as an argument to our method. And that's how you do it. Again, if you're familiar with Play, I think this syntax should be very familiar to you. It should be straightforward. Okay, so remember the service definition we had before? This was in our API project. Now we defined it. Now we need to provide an implementation of that in our implementation project, right? That depends on our API. So the implementation is straightforward in this case. What we want to do is just we get a request message that is the name of the user as part of the path, as part of the, well, it's the request body, and we just return a feature with some text. And that's it, basically. That is all we had to do to implement our LOR service with Lagom. Is there any questions so far? Yes?
I don't understand how name maps to future
yes, so
service call.
Perfect. So the question is, basically, I don't understand how, well, what this syntax exactly means. So name is the request body that is being sent to when calling this, well, this endpoint, right? So in this case, name, the type of name is a string. And we don't need to type that because it's already, well, clear and expressed in the types. So we have a service call of string to string. And we said the first type parameter is the request message. So it's the type of the request message, so it's a string. And the second one is the response message, right? Yes?
The type of that expression would be function string, future string.
Right, that is a good point. So the type of that would actually not be a service call. So I'll tell you that maybe a bit later, why it is the case. But there is an implicit conversion there going on. So it's basically taking a function and transforming that into a service call. But I'll tell you why we do that, or I do that here later on. Is that good enough?
Yes.
Good. So now let's say that I have a different service. I'll just call it my service implementation. Let's imagine that we have the usual service, well, my service API project, and then I have this my service implementation project that implements this API. And the point of this slide is that I want to show you how you can communicate with the LOR service, how easy it is. So all you need to do in the my service implementation is inject the hello service trait that we defined before, and then you can just use it. You can just invoke basically the endpoint that the hello service provides. And that's all you have to do. This is actually communicating for a service A to a service B, it will be that easy. You don't have to do anything. Underneath, as I told you before, when we were exploring the development environment, what will happen is that the implementation of that hello service will basically go and contact the service locator and say, hey, I want to talk to hello service. Can you give me his IP? And it will send you back the IP, and then you will just make web service call to the endpoint exposed by the LO service. But these all happen underneath. You don't see it. It's all basically working. So is there any one of you seeing a problem with this kind of communication? I know this is a tricky question. It's fine if, I mean, it's always hard to answer questions. But there is possibly a problem when you're doing that kind of communication with a different service. So I'll give you a hint. What happens if the LO service is down? If the LO service is down or is unresponsive or you have a network problem, whatever reason it is, basically this service will also look like it has a problem. It may look like it's down, it may look like it's taking a lot of time to answer, and all that not because this service has a problem, but because the problem of the other service is actually basically causing myself having a problem, right? So the reason for that is that because somehow you're doing synchronous communication, even though you're using future and everything, you're still making a request and waiting for a response. Even though this will happen somehow in the future, you're not using any thread and resources. The user that made that request to your service is still waiting for the response, right? And so if that LO service doesn't answer, you'll have, well, the user will say, well, this is really taking too much time. I mean, it's not normal. So failure is propagating down to the caller, which is not something that you want when you're building microservices. Or at least it's something that you don't want. And there are always trade-offs that you have to consider. So my point here is that we have intercommunication that is extremely simple to do, but you shouldn't abuse it. And there are alternatives for avoiding the problem that I just described. I'll talk a bit more toward the end about this, and if you have questions, feel free to, during the Q&A or later on, to just grab me and ask questions. I just want to mention this because when you go and look in the sample application, you'll see things like that. You'll think, okay, this is the way to do it. Well, in a real application, you'll have to think about, how failure is going to propagate to the caller and what that is going to mean for me and, your user. So always be careful.
One question.
Yes.
Does it include circuit breakers or anything like that?
Good. Yes. Actually, thanks for the question. It's about circuit breakers. Actually, we have Lagom has built-in circuit breakers. So it means that that call, if we see that actually is not responsive, well, we're just going to fail it right away instead of waiting. That happens. But failure is still propagating somehow, right? So there are ways to avoid that. And the way you will want to do is having something that allows for asynchronous communication. So that means maybe you want to replicate some of the state of the other services and share it with this service so that maybe I don't even need to make that call because I already have the information. Maybe it's not the most up-to-date information, but it's good enough for our use. So as I said, I'll talk a bit more about this later on, and you're free to ask questions at the end or after the session. All right, persistence API. So this is a really important principle when designing microservices. Each service owns its data. There is no other service that is going to go into my database and basically take information from it directly. You don't want basically to go back to building monoliths, right? Where everyone has access to the database and then you have no clue who's using it. And so it's basically hell to refactor things or change. And you don't want to do any changes just because you don't want to be blamed for those changes. So you're very conservative, you don't make any change, and that is why then we get into these problems of, well, these monoliths that grows and grows and grows, and they become more harder and harder to maintain, right? So, principle, each service owns its data. And if another service needs the data of that service, well, either it will ask for the data through the service endpoints, or there's going to be some other mechanism like a message broker where the service just share its state or part of the state that it believes is interesting for other services to consume, and the other services will consume those information if they want to, so that you have this decoupled architecture, right? And then another thing, As I said, in Lagom, we advocate the use of event sourcing and CQRS. Again, that does not mean that this is the only way of building Lagom services, but it's something that we believe it's a really nice fit for microservices and something that you should think and consider. Then maybe it's not going to be good for your specific use case, but it's good to think about it and consider it as a good alternative. So, in a nutshell, event sourcing is about capturing all state changes as events. So if you compare that with, well, the way we are, at least I was used to do the development, is that I would only know what is the current state. In the database, would only know what is the current state. It would have no clue how did I get there. And I would have actually no possibility to know how did I get there in the first place, right? I only know what is the current state. Well, event sourcing is about, I want to capture all state transitions, and those are actually what I'm going to store in my database. Because if I want to go back and check the state at some previous point, I can just easily do that. Basically, the whole story is stored in your database. And CQRS is about having different models for read and write. And we'll see why that is interesting. So here are some of the benefits of event sourcing and CQRS. I mentioned some of them. It allows you to time travel. As I said, you haven't lost any information about your system, about how you got to the current state. So you can always roll back and check how did you get there. It's an audit log for free. Future business opportunities, it's again all related. Since you didn't decide what you don't need, you have stored everything, your business can actually say, well, you know what, we would really want to expose this functionality. And well, it turns out that we already have a lot of history about that. So basically, since day one, we can offer a very interesting new functionality to our users. There is no need for ORM, no database migration script.
Can you explain this point? Why there is no?
Yes, because there is no conversion or mapping that you need to do between your domain objects and the representation that you have in the database. So the reason is because you're actually storing the events, and the events are what you use in your application to determine what is the current state of the application. This will get a lot clearer, I think, when we see the code. Like, I actually have an example. We want to implement a functionality of our Chirper app, and we'll see how we can do that with event sourcing and CQRS in Lagom really soon. And then, yeah, there are like other ones that, yeah, we can discuss about it later on if you want. So there are basically two parts. One is how do we write, and the other one will be how do we read, right? So we'll start with the writing side. First, we'll have to create command and event classes. So in event sourcing, command are things that I'd like the system to do. It doesn't mean that they will happen, but they're like desires. I'd like, for instance, to add a friend. This is a desire. And events are actually facts about your application. Like, I desire to add a friend. If the system was successfully able to add that friend, then it means that a friend added event will be generated. And this is the event that I'll be storing. The friend has been added. It is a fact. It has happened. All right? And the second thing, so command and events will be just plain Scala classes. Again, we'll see it in a moment. And the other thing we'll have to do is subclassing this persistent entity, which is a class that is part of the Lagom API. And a persistent entity will hold the current state, the in-memory state of the application. So we'll have many persistent entities, and all holding a portion of that state. For instance, and we'll see it soon, I will have a friend entity that will know what are the friends of a user, okay? And in this persistent entity, we will define command and event handlers. So we'll have command handlers for saying, okay, I want to add a friend to my user list. That persistent entity will handle that command, and if it all succeeds, so I can actually add that friend, I will generate an event, So by generating an event, then my persistent entity, what we want to do is updating the current state of the persistent entity, and that is why we will have an event handler also declared in this persistent entity. Again, if this is looking complex, we'll see the code, and I think you'll see it's really easy. And a persistent entity can be accessed from anywhere in the cluster as long as you have the entity ID. So you will be defining entities ID, so unique IDs for accessing the persistent entities that are needed to carry out the task at hand. And if you're familiar with DDD, a persistent entity actually corresponds to an aggregate group. If you're not familiar with DDD, it's fine. I was just going to keep this in for people that are familiar with it. Okay, so we want to implement this functionality. Add a friend in our chirper app. So I'll just move back to here. So let's see, how do we add a friend in practice? We have this, and I think I have a friend. Well, there is someone named not Lagom. And now Lagom is in our feed, right? So this is the functionality that we want to implement. So let's go back to the slides. So let's split this into different steps. We want to create add friend command class. Why? Because we want to express the desire of adding a friend to the system. Then we have a friend added event, because that defines the fact that, yes, I was able to add a friend. So that happened. And finally, we have a friend entity that will have to manage these commands and produce events for these commands. All right? And update the state of, well, the persistent entity, and the sum of all the persistent entities define the current state of the application. So let's start with the first thing. Let's create a command class. Really easy. We just define a trait. It's sealed because we don't want anyone to extend it outside of our compilation unit. And it extends JSONable because we want these commands to be sent possibly across the wire to entities that are not living in our node, maybe, because we are in this distributed environment. And so JSON is going to be the default serialization format for these messages as well. And we defined our class that is just a plain case class. It takes a friend ID, and this reply type is the reply that will be sent by the command handler if it was successful, if the add friend command was successful. So in this case, when the command, the add friend command is successful, the caller will just receive this done object, which just means I was able to do it. I mean, it's just a value that you'll discard. And our add friend, it extends friend command. Again, I didn't have to create a super, well, actually, no, yes, I wanted to create a super class because I can have more than just one command, right? And we'll see that when I declare the persistent entity, I actually need to define what is the class of command that this persistent entity will accept. It's all type check, basically, as opposed as if you've been using akka, where when you're sending messages, your actor don't really know what kind of messages they'll be handling. Okay, second thing, we need to create a friend added event that will happen if I receive a command, add friend command, and I was able to add, and I'm able to add a friend, then friend added event will be sent to the system. Again, it's pretty similar. I just have a different hierarchy. It's friend event, the seal trait. But yeah, again, it's a plain case class with a couple of fields, not really important. My point is that it's just a plain case class, and it's extremely simple. And finally, we need to define this friend entity. The friend entity holds the state of basically what are the friends of a given user. So we define a class, friend entity, that extends persistent entity. The first type parameter is the set of command that this persistent entity is going to handle. The second type parameter is the class of events that will be generated, so friend event. And friend state is the state that will be held by this persistent entity, is the in-memory state that will be held by this persistent entity. And all we need to do is provide an implementation of this initial behavior method that us basically to define the command and event listeners. So the friend state, so this is the state that will be held by our persistent entity. It's, again, simple. We have a user. Well, if we have a user, then it means that I can add friends to this state. And the friend state will keep track of what are the friends of a user. And this will be held by the persistent entity, by this friend persistent entity that we have just did. Good. So command handler. We need to handle this add friend command, right? So we are, this is inside the implementation of the initial behavior method of the persistent entity. And we're just saying, well, when we get an add friend class type of command, well, if we have a user in the state, then we're going to create an event, a friend added, and we're actually going to persist that event. And if that was successful, then we'll tell the caller that it was done. But if we don't have a user in the state, then we can't add a friend. And this is how you do validation of the command. So a command may or may not generate an event, as you can see here. And finally, what happened is that we persisted an event, but the state of the persistent entity didn't change, right? So we need to define an event handler that say, well, when a friend is added, I want to update the state of the persistent entity. And in this case, again, it's straightforward. I just want to add the friend to my current state so that the persistent entity now has the right state, right? If I'm going to query the persistent entity for, like, can you give me the friend of this user, the persistent entity will know it will know about this user, this friend that we just added to the persistent entity. One important thing is that you must not do side effects here. And the reason is because you're storing all events, right? And the idea behind event sourcing and CQRS is that you can rebuild the current state by just looking at the events, right? So what is the problem if you do side effects there? Well, this persistent entity, let's say that a node crashed, and then I need to spawn up a new machine, and I need to rebuild the current state. So how do I do that? Well, I just replay all the events that have been stored for the persistent entity, right? And if I do side effects there, like I'm sending, let's think about like I have a persistent entity for an order, and I'm sending an email there to the user like, yes, your order was carried out. Well, then I'm rebuilding the state, and I'm going to send this email over and over and over and over and over. So that's not where you want to do side effects. There is a different place where you want to do side effects, and that is actually here. This is the place where you can do side effects because it's only going to be called once when the event is persisted, and the event is only persisted once. Okay, so now that we have all these different things, let's bring them together. We have a friend service, again, pretty similar to before. We have an endpoint, and we have an add friend method that we need to implement. And this is the interesting part. This is how we implement it. So we'll have to inject a persistent entity registry that basically knows how to contact and locate the persistent entities that are existing in your system. And this is how we get the reference to the persistent entity, to the friend entity that we created. The second one is the user ID, meaning that it's the entity ID that we're interested in, because we want the entity that holds the state for this particular user, not for any user, right? And then we just call ask and pass the command, and eventually we either get a problem, so as we've seen before, there is validation, so it will either succeed or not, but anyway, something will happen. So, yes, I'm running out of time, so I'll be fairly quick on the read side. This was the write side, but you'll also want to possibly, how do you say, like, usually when you want to query your CRUD databases, what happens is that you have possibly joins across tables, and your tables, you only have one kind of table, right? It's the one that you use for write, you use for read. So the idea here is that, well, for writing we use event sourcing, we're storing events, and that may not be the best format when I read, just because I want to mangle this information in a slightly different way. It has to be adapted to the view that I'm going to present to the user, and also that view may evolve over time, so the actual representation might be different. So that's the idea about having different representation for write and read. And in Lagom, for the read side, what you will do is that you will subclass Cassandra read side processor. It's just a class that allows you to define tables. In the specific case, it's tied to Cassandra, so it will be Cassandra tables. And you will declare event handlers that update your tables, right? So the persistent entity, as we've seen, generate events. And then here on the read side, what we will do is that we will listen to those events and update our tables, our query tables, so that then in our service, if we need to access these tables, we can do that through Cassandra. It will be just through the Cassandra query language. So running in production, Lagom use native packager for for creating executables to run your Lagom services in production. Lagom, yes, Conductor is the preferred path just because it has built-in support for Lagom. It is not the only path, but it's definitely the easiest path. Conductor is free for development, and it's actually not free for use in production. So if you're interested in that, happy to talk more about it. We actually have the Conductor team here at Scala Days as well, so I'm sure they'll be happy to talk to you about it more. And by using Conductor and our Reactive platform, you also get monitoring, split plane resolver, and lots of other things, support, and lots of other things. So current Lagom is that we're in RC1, so it is definitely the right moment to try it out and tell us if there is any problem, because it's going to be final soon. And that is actually to answer your initial question. Right now, there is only a Java API, so everything I show you actually compiles. It's all fine. But that's why we need a couple of implicit conversion here and there to adapt the Scala types to the Java types. But hopefully you'll feel like me that actually using Lagom through the Java API with Scala, it's pretty okay. Like, yeah, at least I feel that way. It's actually pretty okay. I can reap all the benefits of using Scala, all the nice syntax things that we get from Scala. And this is a link to the sample app that I've been using in the slides so that you can explore it more. I'll actually tweet these slides soon, so if you follow me, you don't have to write down any of these links. This is the future, so we're going to add Maven support, maybe not that interesting for some of you, but we think that it's really important for getting companies into using Lagom, since it's a well-defined standard Maven. There is no order in this list. There are things that we want to do. Message broker integration, which is for resolving the initial problem that I mentioned about having services communicating synchronously. Again, happy to talk a bit more after, during the Q&A or after. Scala API, support for other orchestration tools, Swagger integration, support for writing, integration test, support for other databases, and lots of other things. And of course, you're welcome to suggest your own preferred feature. These are a few links that may be useful. Again, I think you can just look at the slides later on. And yes, thanks everybody. Sorry for being a bit long.
We can have a little Q&A. So if you want to ask questions, go for it. Just raise your hand.
Really good talk. Quick question on your cluster manager integrations. I mean, do you have any plans of integrating it with either Mesosphere or the DCOS of Mesosphere, or making it as a service?
So, really good question. There are definitely plans in the Conductor team for integrating Conductor with Mesos. I don't know all the details, so I don't want to say anything incorrect. So I'd actually encourage you to come to the Lightbend booth and talk to the Conductor team, who definitely has a better answer for this kind of question. But there are plans, as far as I know. Hopefully I'm not wrong. If Christopher is in the room, he can correct me.
When will the Scala API be released?
That looks like James to me. I don't know. So our tech lead is working on that, but he's being a bit slow. No, I'm joking. Anyway, we're working on it. So we have one person working on the Scala API. It's a massive work in order to provide an API that actually feels idiomatic for Scala. So it will be there, hopefully soon. Yes. Wait. There is one question here and one here.
How easy is it to integrate with services that aren't in Lagom?
Yes. In development, we actually have a couple of things that you can do to integrate with external services. For instance, to integrate services into the development environment, there is an SBT setting where you can just provide an HTTP link to your service together with a name so that it gets registered to the service locator so that you get the same kind of benefits as if the service was written in Lagom. And we have a couple of more things that we'll be doing for facilitating, integrating with external services. And I think, yeah.
One small question. How big should be microservice or how small? I mean, it's a really complicated question. Nobody can answer it, and probably it's dependent on organizational task. But could it be possible, for example, microservice cover one feature, one big feature, for example, for some product, and have to manage if you will get 1,000 feature and 20 development teams which will produce new feature each time? How also it will be?
It is a really good question. I think we have the same problem without talking about microservices. We have the same problem when we design a class and we wonder, is this something that should be a responsibility of this class, or should we put it somewhere else? It is a question that doesn't have a straight answer. I think that one interesting way to look at it is to think in terms of DDD. And so look at DDD as a way of defining your boundaries and how you should be splitting your services. So I don't have a straight answer, but I'd suggest you to look into DDD as a possible ways of how do you want to split your services.
Is it possible to use Lagom without subscription to Lightbend Reactive platform in production?
Absolutely. Thanks for the question. Yes, Lagom is open source and can be definitely used without any of our commercial offering. So yes, you can use Lagom without Lightbend. Conductor, you can use it. That Conductor is part of our subscription. So you can use it. Is free for development. So you can use it for development, but it's not for free in production. Companies have been using things like WebSphere and other runtime environments, and they've been fine paying for those things. And this is part of how we actually can survive, and that's why Conductor is part of our commercial offering. But if your company doesn't want or can't afford Conductor, there are alternatives. There is actually the Conductor tech lead that started a project for providing support in Kubernetes. It's early days, but you are welcome to contribute to that in Kubernetes. You can use it for free, for instance. And there are also ways for running it outside of an clustering tool like Conductor or Kubernetes. The only thing that you actually need to run Lagom in production is an implementation of the service locator interface that we provide in Lagom. So as long as you have an implementation, then you can do it. But then you'll have problems with what happens when one of your services crashes. If you're using things like Conductor, well, it takes care of that for you. While if you don't use one of these tools, then you'll have to manually do something in these cases. So it really kind of depends on what are your needs.